All right, here comes the FRQ. This is number 2 from class. Today, yesterday, whatever day it was, I don't know. I'm not even ready here. Hold on, I got to get my colors. This is the one about, is a graphing calculator one about water getting pumped in and then also removed from a tank. So that's what I'm doing. All right, so it gives us the table that is R of T, and that is removed. So I wrote the word removed there. And they give us W of T, which is the in, right, being pumped into. So I am going to go ahead and on my graphing calculator, I'm going to plug in this equation into Y1. So 2,000, and then E, I don't have my glasses on, so I hope that says E, raised to the power of, now that's a negative, not a subtraction, so the negative, and then X squared divided by 20. All right, so there is the equation. I'm going to set this aside. So, and then it gives you more information about it being a decreasing function from 0 to 8. And at t equals 0, there is 50,000 liters of water in the tank. So A asks us to find R prime of 2. So R prime of 2, and it says estimate. So we're going to use the chart because that's where R of t comes from. And we're going to use the sandwich. I call it the sandwich. It's the slope. We're going to go from R of 3 minus R of 1, because 2 would land in between there, all over 3 minus 1. So those values from the table are 950 minus 1190 all over 2. And then you would work that out on your calculator. So I'm going to go to second quit. 950 minus 1190 equals, divided by 2, and it is a negative 120. And then units of measure are important on this one. You actually get a point for it. So it is going to be, since this was liters per hour, and then we did a derivative of that, it's liters per hour squared. So you get 1 point for the negative 120, 1 point for the units of measure. All right. B, part B, asks us to use a left Riemann sum with 4 subintervals indicated by the table to find the total amount. So usually they put the integral so you can see it. They didn't, so I'm going to. So it'll be the integral from 0 to 8 of R of t dt. And we're doing a left Riemann sum. So in the table, I'm going to come up here. In the table, I'm going to start on the left side. So 1,340 times 1 plus 1190 times 2, the difference in the x values, plus 950 times 3, and plus 740 times 2, right? And then that's where you get to use your calculator. You're going to put it in your calculator. If I remember correctly, it's 8,050, and it's liters. So we get a point for the setup, all of that, a point for the answer, and then it asks us about, is it an over or an under? So I'm going to draw a little picture. It told me in the question that R of t was decreasing, plus I can see that from the values, they're going down. So you can draw that however you want. I'm just going to show it going down and show that it doesn't matter how you draw it. We don't know anything about whether it's concave up or concave down so much. So I'm going to do a left, so come off the left side and over exaggerate the rectangle so you can see it's an over. So we're going to say 8,050 is an over estimate since R of t is decreasing and using LRAM. So that is another point. So we are at 5 points right now going into part C. Part C says use the answer from part B to find an estimate of the total amount of water in the tank to the nearest liter at the end of 8 hours. So they gave us information about the rate going in and the rate going out. So to find the amount of the water, I'm going to use a new function AFT. It's going to take into consideration that there was that 50,000 at the beginning. Can't forget that. And then we're going to go 0 to t. And then it's going to be WT minus R of t dt. And then this is where I got into trouble the other day, is this part. So we're going to have, for integrating what we want, it's the 50,000, right? Plus, we're going to integrate from 0 to 8, WT. And then we are integrating, we're going to subtract, I'm going to break that apart. Integrate from 0 to 8, R of t dt. But remember, we aren't given an equation for R of t. Whoops, so sorry. I'm a klutz. What we're going to do, what it was referencing, is we're going to use our answer from part B that gives us that integral. So we have 50,000 plus the integral from 0 to 8 of WT dt. You're going to use your calculator for this piece. And then you're going to minus 8,050. All right, so let's see how this works. I'm going to clear my calculator. Remember, I already put in W of t in my calculator. It is Y1. So I'm going to start with 50,000 plus math 9, 0 to 8 of alpha trace Y1 dx, right? And then minus 8050, enter. And we get the answer 49786. It said to go to the nearest liter, so that's what I just did. That's in the tank. So I forget the breakdown in points. Hang on, I need to take a quick look at behind here. So we get a point for the setup and a point for the answer. So I believe we're at 7 points right now. Okay, and now we're going to do part D. So part D was the part that I did not like, me no likey. And it's just because I'm used to being given information to make it easier. So it's just because I haven't come across one, so my experience was not up to par for this one. So it's talking about over that 0 to 8 time frame, that water's pumped into the tank. They want to know, when is it the same as when it's removed? Explain why or why not that time t exists. So I knew I wanted W of t to equal R of t. We want them to be the same as. So we would normally subtract this over and get it equal to 0, because normally on these questions you have equations and you could put these in and find where it crosses the x-axis, and that would give you the time t. But the issue here is we don't have equation R of t. We don't have it. So we can't actually work this out. We're going to have to think it through critically, right? So here's what we're going to do. We're going to look at time t equals 0. We have to look at this interval. So W0 minus R of 0. What does that look like? Well, remember, I'm going to move this up here. So W of 0, now you can do this on your calculator, but you don't have to. If you plug in a 0 here, this whole thing will be 0. E to the 0 is 1. And so we would just have 2,000, right? You could just think that through. 2,000 minus R of 0. R of 0 is in the chart. It's 1,340. And I can tell that that's going to be a positive number. It's greater than 0, right? So I'm going to do a little graph here just to show you. So at 0, our point is above the x-axis, right? It's above. Now let's look at t equals 8. So we're going to do w of 8 minus r of 8. This time we're going to need to use our calculator. So I'm going to turn it on. I'm going to go to the y equals. I'm going to graph this thing. And I probably need to change my window, because my window is at negative 1.5 to 1.5. So I'm going to change it. I'm going to go 0 to 10 to give me room. So I'm going to let it graph it. If it's turned on. Do you think it's turned on? Let's go look. It is turned on. Okay, let's hit graph. And maybe we can't see it. Maybe it's so far out. So let me do this. I'm going to zoom out. Zoom 3. You probably do this and you think it's you, but it's not you. It's just, see, the graph is higher. I'm going to zoom out one more time so you can see it. So the graph was way above the x-axis over here and we didn't see it, or we were missing it because we were in this little section. So I'm going to hit second, calculate value, and I'm going to plug in an 8. So when you plug 8 into w of t, it's 81-ish. And r of 8 comes from the table, which was 700. So obviously that's going to be less than 0. It's going to be negative. So again, my little drawing over here, if this is 8 and it's down here, what has to happen in the graph for you to go from here to here in a continuous function? It has to cross the x-axis. So here's what we're going to say. By intermediate value theorem, that's what they want us to say. By the intermediate value theorem, there exists t on 0 to 8 where w of t is equal to r of t, since the function is continuous and changes from positive to negative, therefore crossing the x-axis. Crossing x-axis. Ta-da! So you get a point for considering this, w of t minus r of t equals 0 equals 1, and a point for explaining that it's intermediate value theorem. That is FRQ 2 from today.